Number 32 says, on the accompanying grid, graph the following system of equations over the interval -6 to 6. So on the interval x is -6 to 6, we're going to graph these two equations. X squared plus y squared equals 25, and x times y equals 12. Okay, the first we should recognize as a circle, because a circle is x squared plus y squared equals radius squared, right? And in this case, the radius equals 5. And there's no translations or anything going on here, so this is a circle centered at the origin of radius 5. Right, so let's go and graph that right now. So we're going to go 1, 2, 3, 4, 5, 2, 3, 4, 5. And the reason I'm counting up 5 like this is because in MS Paint, if I want to graph something, if I want to graph a circle, I have to do it in this fashion. So there's your circle of radius 5 centered at the origin. Okay, that's your x squared plus y squared equals 25. Done. Oops, undo. Okay, now this other one is x plus y equals 12. Okay, so let's put that into a more standard form. Let's rewrite x times y equals 12 as y equals 12 over x. And keep in mind that we're only going to use values of x between 6 and -6. So we'll just keep tabs. We'll make a little xy chart here, x and y for this function. So we've got -6, -5, -4, -3, -2, -1. Okay, and you should see that for x is 0, the function is not defined. So if x is -6, 12 over -6 is -2. If x is -5, it's going to be -12 over 5, which unfortunately does not reduce. Okay, if it's -4, so 12 over -4 is -3. If x is -3, 12 over -3 is -4. If x is -2, then 12 over -2 is -6. And if x is -1, 12 over -1 is just -12. Okay? So we have that part. So let's go and plot some of those points. We'll use the color red. And so we're going to plot -6 and -2. That's that point there. We'll plot -5, -12 over 5. 12 over 5, that's a little bit more than half. So I guess more than 2. So I guess we'll plot it about there. Okay, -4, -3, that's easy to do. -4, 2, 3, -3. Now that looks like it might be an intersection point. We'll have to go back and check on that. Then we have -3, -4. So we go back -3 and down 4. Again, it looks like that's a possible intersection point. -2, -6. So 4, 5, 6. Okay, and -1, -12. So 6, 7, 8, 9, 10, 11, 12. It's going to be somewhere way down here. It's going to be way down at the bottom. So that's the curve that we have. Okay, and it's going to look something like, oops, not going to look anything like that. It's going to look something like this. There we go. Okay, and then we should also do this for positive values. So let's go and do this also for positive values. So we'll make an XY chart and we'll graph it. And we should know there's symmetry here, but just to be complete, 4, 5, 6, we'll go through and do it this way. So if x is 1, y is equal to 12. If x is 2, 12 over 2 is 6. If x is 3, 12 over 3 is 4. If x is 4, 12 over 4 is 3. If x is 5, we have again 12 over 5, which, like I said, doesn't reduce. If we have 6 equals x, we have 12 over 6, and that is 2. So again, we'll go through and we'll plot the rest of those points. So let's plot x is 1. That's going to equal 12. And again, 12 is way up over here somewhere. If x is equal to 2, y is 6. So 1, 2, and then we go up 1, 2, 3, 4, 5, and 6. If x is equal to 3, y is equal to 4. So 3, 1, 2, 3, 4. Okay, and again, that looks like it's an intersection point right there. If x is equal to 4, y is equal to 3. So 4, 1, 2, 3. And again, it looks like it's an intersection point. If x is equal to 5, y is 12 over 5. So 5. You know, that's going to be a little bit more than 2. That's going to be something like that. If x is equal to 6, y is equal to exactly 2. Okay, and again, we can see our curve does something like this. It just touches the circle, maybe goes inside it a little bit, and then it's on its way. So I'm just going to go out on a limb and say that the points of intersection for this curve here, and we'll write them in blue, are going to be this point and this point, as well as this point and this point. And those are, as we said, the points 3, 4, and the points 4, 3. And this is the point -4, -3. And this is the point -3, -4. Okay, so I'm going to say that these guys are our points of intersection. Now you can go back in and verify that they work, and you should do that. And here is the graph that I made using the program called Geogebra, which again, I can't emphasize how nice that program is. It's free. And we can really, really clearly see here that the point 3, 4, which is right here, that's an intersection. The point 4, 3, clearly an intersection. The point -4, -3 is an intersection. And the point -3, -4 is an intersection. Let's just verify that this works real quick. Okay, I really want you to see. We'll just do just one. We'll do the point 3, 4, just to show that this is true. Okay, so 3 squared plus 4 squared should equal 25. Does it equal 25? 9 plus 16 equals 25. Check, it works. We should also have 3 times 4 equal to 12. And again, 3 times 4 does work. Okay, and that's coming from x squared plus y squared equals 25. And here is x times y equals 12. So we just verified that that point works, and you can verify that all the other points work in a similar fashion. You know, 3 times 4, 3 and 4, that'll obviously work, and the other ones you're reversing the signs, but it doesn't matter because negative times negative is positive, and when you square a negative, it becomes positive. So all these points are indeed the correct points.